Hello, I'm Papia. In this problem, we have to evaluate a limit. And the limit is, as x approaches to infinity, of x times sine of 1 over x. So this is the limit that we have to evaluate. Now, what do you usually do when you evaluate a limit? Well, we directly substitute, right? Now, notice here x is approaching to infinity. Infinity is not a number. It just means that x is taking large values, right? But still think about it. If you do plug in infinity, say, like plug in the sense of understanding what that means, what will happen to x? Well, x will approach to infinity, right? As x is approaching to infinity, of course, this x will approach to infinity. Okay, what will happen to the portion that has sine? Okay, now notice, sine of 1 over x. So infinity is now going to be in the denominator, which means the denominator is getting big, which means 1 over x will get small. So this portion will approach to sine of 1 over infinity, or sine of 0. And sine of 0 is 0. So direct substitution is giving you infinity times 0. What does that even mean? We don't know, right? This is an indeterminate form. We don't know what the answer is with a direct substitution. Therefore, we have to figure out a different way to solve this problem. Now, if you recall, we know about some special limits, and one of them actually involve the sine function. Do you remember what that limit is? It is limit of the function, say, sine of t over t, as t approaches 0 from the positive side. And the special limit is 1. So you already know this. What we should try to do is, see this function here? Can we rewrite this function in this form? If we can, and change this limit as well to t approaching to 0, we know the answer. So sometimes we have to do that, okay? We have to do a little, what we call is a change of variable. So let's think about it. What should we define this new variable t to be so that this function changes to sine of t over t? So the clue is right here. Look, we want sine of t, but we have sine of 1 over x. So why not say t is 1 over x? If we do that, let's see what happens. Okay, so if this is the change of variable, so we are going to write down our limit. We'll discuss what limit it is just in a few minutes. Okay, so let's rewrite this x. If t is 1 over x, x is 1 over t. So x becomes 1 over t, and then we have sine of 1 over x. That's how we defined our t. So the function changes to sine of t divided by t. That's exactly what we want. Now, let's think when x is approaching to infinity, so x approaches to infinity, then where is t approaching to? Well, t is 1 over x. So x is getting bigger, denominator is getting bigger, so 1 over big is small. So t is approaching to 0. And actually, it will approach 0 from the positive side. So here, the limit actually changes to t approaching to 0. That's exactly what we want, right? And we already know what the limit is. So let's rewrite this one more time. This is limit t approaching to 0 plus, and I'm rewriting the function, sine of t times 1 over t is same as sine of t divided by t. And we know this is a special limit, and the answer is 1. So even though originally the function looks different than the special limit, it actually is the same function. And we can do that by a change of variable. Thank you.